Section 11.7, Applications of the Definite Integral to Business and Economics. There are several applications we could look at in this section, but we are only going to be focusing on two. And those two applications would be consumers and producers surplus. So I have a graph here for you to look at, and included in the graph is the supply curve, and we're going to call that S of X, and then the demand curve, and we're going to call that D of X. Where these two curves intersect is going to be called our fixed unit equilibrium point. So this point is made up of what? Well, it's going to be made up of the quantity demanded and the fixed unit market price. All right? So let's see how this works. Actually, before we do that, understand, this is going on right now in our society in terms of various commodities, like toilet paper, for example. I mean, the demand for toilet paper right now is through the roof, and therefore the supply is very limited. So anyway, we're not going to be talking about toilet paper specifically as we progress through this section, but that's just one example of many based upon the fair market economy. So I'm sure you'll talk more about this in your economics classes and other business classes down the road. Again, we're just going to be touching the surface on two concepts here in section 11.7. And the first being consumer surplus. So suppose we have a demand function, D of X, and it will be relating to our unit price P of some commodity to the quantity demanded X of whatever the commodity is. All right, so suppose a fixed unit market price P bar has been established for the commodity, and corresponding to the unit price is the quantity demanded X bar. So that's this equilibrium point right here. So if we have this point established, then those consumers who would be willing to pay a unit price higher than P bar for the commodity. So in other words, they would have been willing to pay maybe an amount up here or up here or up here. Well, if they were willing to pay that a price higher than P bar for whatever the commodity is, they would in effect experience a savings because they're paying this amount, all right, less than what they would have been willing to pay. Okay, so the difference between what the consumers would be willing to pay for this amount, X bar, of whatever the commodity is, and what they actually pay, which is this P bar, okay, is called a consumer's surplus. That's what we're going to be determining, first of all, in section 11.7. So do you see how the integral would be helpful here? All we're going to do to determine consumer surplus is first figure out the area under this curve, under the demand curve, from 0 to X bar, and then what are we going to do? We can figure out the area of this rectangular region, which is just X bar times P, and subtract off this area from the overall area underneath the red curve to get consumer surplus, all right? This is the difference between what the consumers would be willing to pay for X bar units of a commodity and what they actually are paying, consumer surplus. Let's see how this works. Okay, so based off just what I was telling you, looking at that graph, this is going to be our model to find consumer surplus, okay? So consumer surplus is equal to what? It's going to be equal to a definite integral, and the limits of integration are going to be from 0 to X bar. And what are we integrating? The demand function with respect to X. And then what are we going to do? We're going to subtract off P bar times X bar. All right, this is representative of the area of a rectangle. Okay, so again, D is the demand function, P bar is the unit market price, and X bar is the quantity sold. Okay, here it is. We're going to look at the integral of this curve from 0 to X bar. That'll take care of all of this area right there. And then we're going to subtract off the area of this rectangle, that's X bar minus P bar, and we'll have our answer. Let's look at an example.